17. So first we're going to start with some vocab. I'm going to tell you which ones you guys are going to want to write in your notes. Definitely I would say this one, go ahead and copy down in your notes really quick. The coefficient of an expression is any one factor of the expression or any product of factors of the expression. Move down. So a numerical coefficient is an expression, or of an expression, is a coefficient that consists of numerals only. You don't need to write that one down. A literal coefficient of an expression is a coefficient that consists of variables or letters only. You don't need to write that one down. This is the important part. I definitely want you to put this. This is what we're really worried about in this class. The coefficient is always on the front of the term. We're going to go over some examples, and hopefully this will make more sense if you're not familiar with the word coefficient. Yeah, what's up, Evan? Yeah. There, put everything. So determine the coefficient. So I told you guys when we were taking notes, the most important thing to remember is that the coefficient, we always want to be on the front of the term. So what do we think the coefficient for 4xy is? 4, yeah. So the coefficient on this is 4. Okay, how about this next one? Negative 15 PQ, what do we think is the coefficient? Negative 15. Nice. And finally, we have 81 XMZ. 81, nice. All right, you guys don't have to write this little note I put for you on the bottom, but I wanted you guys to know, because the number piece should always be written in the front of our term, so when we have terms like this, we should always put the number first. We usually think of a coefficient as a numerical coefficient. So all those definitions that were on that first page are in the book. If you guys are curious, if you guys want to read the book on your free time, I know you want to. We usually think in the math world, the coefficient is usually just the number on front of the term. So if you guys hear coefficient, probably forward in life, it's almost always just going to be the number on the front. So I just wanted you guys to know that. All right, now we have a new word, factors. Go ahead and write this down. A factor is any numbers or variables that can be multiplied together to get the original number. So I think you guys are probably the factors for 81xmz, 81xmz. As far as we're concerned, factors are just breaking it up. What all did we have to multiply together to get the final term? Maybe put one of those examples in your notes, just so when you have to label those guys or figure those guys out in your homework, you know what we want. Okie doke. Not super hard stuff, just new vocab. Everyone good so far? Any weirdness? No? Perfect. What is a term? Another thing I want you guys to write. A term is something that is separated by pluses and minuses. So let's look and see. How many terms are in the expression? I want you guys to look at this really quick. Hold up with your fingers how many terms you think are in this expression. I see some that I agree with, some that I don't. There's sort of a tricky one in here. The tricky one should have given you less, Isaac. Okay, I see lots of 4s. 4 happens to be the number that I agree with. And I'll show you why. So we have x is definitely 1, right? 4xym is also definitely 1. This is a tricky one, but this is actually just all one term. And the reason for that is these pieces are attached by this division bar. This division bar makes them one term, and they're separated. This one's separated by this plus, this one's separated by the minus, this one's separated by the minus. And then we have this final 8 right here. But this plus 2 on the bottom does not make this 3 different terms, it's all scrunched together and attached by this division. Okay, so they have to have a minus sign with nothing else happening on it are the ones that break up this expression. 4 terms. Yeah, because all of this is one piece right here. This division sign makes it so it's this divided by y plus 2 on the bottom. When we separate the terms with plus and minuses, they have to be a minus with nothing else going on. So if maybe you want to think about it like this minus sign has nothing on top of it and nothing on bottom of it, so it definitely breaks up the terms. There's nothing else happening. That's a plus or minus all by itself. Those are what break up the terms. All right, here's some really important stuff that really made for some sort of confusingness for the surface area lesson, so I apologize for that. We will be doing more examples of those, so don't worry. Hopefully the ones in the homework so far haven't been too bad. They've been pretty basic surface area problems. You can always come in and get extra help, but we will do more examples. So this is the distributive property. This yellow box is definitely something that you should have in your notes. Technically, this, I guess, is the distributive property of multiplication. We can also just think of it as just plain the distributive property. So the distributive property tells us that for any real numbers a, b, c, a times quantity b plus c equals ab plus ac. So some of you guys, I could tell when we were doing that complicated surface area problem on the whiteboard, some of you guys do already know how to do this. If you don't, it's totally fine. It's a pretty simple thing. All that's happening here when we have a times b plus c is basically we're just distributing out that a to both the b and the c. That's why it's called a distributive property, because we're distributing the a. So then we get ab plus ac. This is going to be something you use for the rest of your life in math, even if that just means to the end of high school. If you want to do math in college, you'll still use it. Very important. Okay, so this first one, it wants us to evaluate by adding, then multiplying. So what it means is we're just going to do our regular order of operations, So first we're going to do the parentheses, right? So if we're doing it by adding, then multiplying, we're going to have 4 times 5 minus 3 gives me 4 times 2, right? So then if we do that just by adding, then multiplying, we're going to get 8. Now it wants us to evaluate by multiplying, then adding. So this is telling us, well, I want you to do the distributive property. So we can draw these little arrows if we want. So first we're going to do 4 times 5 gives me 20. And then we're going to do 4 times negative 3. Okay, if there's a negative in front of a number when we're distributing, it stays with that number. This is probably something that's going to be sort of tripping you guys up at first. Those negatives need to stay with the number. So I'm going to do 4 times negative 3 gives me minus 12. 20 minus 12 also gives me 8. So this is just showing this distributive property rule really does work. It will work all the time. Use the distributive property to evaluate. So everyone go ahead and write this example down. So we have 4 times quantity 6 minus 2 plus 5 minus 7. And we want to use the distributive property to evaluate. So basically use the distributive property to solve this problem we have on the board. So what we're going to do is I'm going to do these little arrow guys. If you guys want to do that also, that's totally fine. What's up, Riley? No, there might be some probably for today's set and maybe the next set it'll ask you to do it both ways, but if it doesn't ask you, No, just solve it. Okay, so I'm going to start by doing 4 times 6, which is going to give me what? 24. And then 4 times negative 2. So just to remind myself, I'm going to remember that that negative stays with that 2. This negative stays with this 7. 4 times negative 2 gives me minus 8. 4 times 5 gives me plus 20. And 4 times negative 7 should give me minus 28. All right, now I'm going to add all these guys up together. I'm going to do it like we did a while ago. We're going to team up our negatives. Negative 8 minus 28 gives me negative 36. Very good. And then if I want to do my positives together, I think I want to do my positives in red. We have 24 plus 20 is going to give me 44. So 44 minus 36, our positives win, right? And I believe that should give me 8 for my answer. Expand using the distributive property. So now we have variables happening. Definitely another example I want to see everybody writing down in your notes. This time we have 2m times quantity xy minus 3p. So this time we have letters happening too. Totally fine. Distributive property works the exact same way. So again, I'm going to go ahead and draw my little arrows in. And I'm going to remember that this negative needs to stay with this guy. Okay, so I'm going to multiply 2m times xy. What does that give me? 2mxy, perfect. 2 times n times x times y, 2mxy. And then I'm going to do 2m times negative 3p. Now it's a little bit trickier. What's that going to be? Negative 6mp. Okay. So what I did was I multiplied my numbers together, and then the m and the p multiplied together just as mp. Okay, everyone should have that example down. You guys will encounter these, I promise. Here's another one. Now we have 3 terms. Okay, I can do it. Okay, first I'm going to start by doing xy times a is going to give me xya. Xy times b, I'm going to get xyb. Xy times negative 2c. Remember I said it's always preferred if our number comes first, so we're going to have minus 2cxy. One more down here. Oh, now we have our extra thing on the outside of the parentheses on the right. So what we want to multiply together, this guy's on the right. That's fine. I'm just go ahead and write my arrows in the other direction. Still works just the same. Or if you preferred, you could cross this 3b out and put it on the front. Works just the same. Okay, so this time I'm going to start by doing 3b times x, 3bx plus 3b times y, 3by, minus 4c times 3b. What is that going to give me? What'd you say, Caleb? Perfect. Minus 12b